Hello, welcome back. Today we're going to look at another basic game that we're going to try and implement in Elm. This again comes from Usborne's computer space games, which you can get if you search for Usborne children's books, Usborne computer space games. You'll find a PDF over here. This is a book from 1982, which gives you some very simple games that you can write in BASIC to run on a computer that was made in 1982. We're going to look at Moonlander. You're at the controls of a lunar module which is taking a small team of astronauts down to the moon's surface. In order to land safely, you must slow down your descent. But that takes fuel, and you only have a limited supply. The computer will tell you your starting height, speed, fuel supply, and ask how much fuel you wish to burn. It will then work out your new height and speed. A burn of 5 will keep your speed constant. A higher number will reduce it. Try to have your speed as close to 0 as you can when you land. Can you land safely on the moon? Right, so one of the mistakes we made last time is the logic of the game wasn't clear enough early on. So, and I think that might have been because we didn't think of the sort of state machine that a game has and the states that we wanted it to be in. Looking at this, I can see there's a state at line 110 where you're inputting a number. There is some reporting of where you are, the time, the height, the velocity, and the fuel you have left. Those are sort of I suppose some kind of telemetry or instrument readout. Then at the end there are 3 crashed states you can end up in. You can either crash and you're all dead if your velocity is too high. You can land okay but with some injuries. Or you can have a good landing. So I think this time we'll start with putting some of those states in. Then we'll see if we can write a kind of tick function that ticks the clock and, given a burn, updates the model with a new velocity and so on. And then we'll see if we can tie it all together with a UI that makes sense. Right, so starting off, I'm in Ellie, and I've got basically an Elm application that does nothing. So it has no model to speak of. It handles no messages, does no updating, and I've just added in the header, Moonlander here. But it compiles. We can reformat it. So let's start off. Like I say, we should really think about these states. So there's one state you're in where you're kind of entering your burn data. Let's call that inputting. That's an awful word. And we're probably inputting a string, I'm guessing. Then there's a state where you're falling, and there's some telemetry. Let's invent a type for that. We've probably got some initial telemetry to go on there. And then there's a state where you've landed and you land, let's call this crash status for now. We'll come back to the names later. So what do we need? We need a type for this telemetry. And we had a height, I think, which would be a float, reasonable. A velocity, another float. Height, velocity, there was a time, which we can use an integer for. And what else was there? Let's have a quick look. Oh, and fuel. And your fuel remaining, which again is a float. So that looks reasonable, I think. We need a type for our crash status. And I think we either landed safely or we had a bumpy landing or we had a perfect landing. Let's just give that a bit of a format. Oh, I don't know why that hasn't formatted. Maybe because it doesn't compile yet. Something went wrong. Oh, that's a type, not a type alias. Okay, let's give that another shot. There we go. So in our initial model, I guess we're falling. Yeah. And we're at a certain height, which I think in the game is 500. We have a velocity that's 50. We have 120. Time equals, let's start it at 1. Just looking at the code, there's this +5 that keeps appearing. I think that must be the force of gravity. So let's add gravity into our model. And we'll set that to 5. Okay, and we've got a couple of messages where we're input string. I think this maybe wants to be a float. Yeah, I think maybe a float. So we're going to input a string, or we're going to we're going to press the button to trigger the burn. That looks good. So now, because we've modelled our model as a set of states, and our message doesn't really respond to those states, it isn't broken down in the same way, I think we're going to have the same issue as we had last time when we come to write our update method. Where we have this nested kind of model and message thing. Which wasn't really very nice, but let's go with it. So let's switch on. Well, the model has more states, so let's switch on the model. Case model of. We need to work out what to do with the messages when we've landed. In that state, nothing else can happen, so we just return the model, I guess. When we're inputting the telemetry, I guess we want to stay. But we want to take. Oh, hang on. So here we'll do case message of. And when we input new burn amount, we want to stay in inputting, and we want to string to float that new burn amount. And if we have a trigger burn, we want to switch to falling, I think. And we want some kind of method that, let's call it tick. For no other reason than we'll call it tick. That takes the current burn amount and the model and the telemetry and returns. Is it always going to return a falling? No, sometimes it's going to return a crash landing. So, well, that's okay. And the last case is if we're falling. And if we get a message of input new burn amount, we want to go to this, yeah? To do this. But if we try and trigger the burn without having entered the thing, we just want to model. Let's compile this. We haven't written this tick function yet. So let's write a dummy one. Tick. And what did we say it was going to take? It was going to take a burn amount, which is a float. Actually, a maybe float, isn't it? Let's write one that takes a float. We'll handle the maybe elsewhere. And some telemetry. And it's going to return a model. And we're going to return crawling. And maybe we'll, for now, we'll just update the time. So we only want to call this if current burn amount is a valid float, right? So I think we can probably do that here. We can say I'm inputting that. And write another case, inputting telemetry nothing. And we just want to return model. Let's see if that compiles. So that compiles. Doesn't do anything yet, and you can't really see the game in here. But we'll work on that. Let's get our view showing some of these states. So, case model of landed crash status. We probably want a div with a header and end game crash status. We'll write that method here. End game status. Case status of perfect, I think we called it. We'll return a div with some text that says perfect landing. Status of, now I'm writing a lot of code without running anything. It's partly because I think this is going to be relatively straightforward to get up to a point where it's working. And the interesting stuff is, once it's working, how we change it to make it more readable and more sensible, and what we can learn from it. A few casualties. Basically, Aldrin has died and crashed. We got a crash or crashed? Landed safely, bumpy, perfect. That's not right, is it? So it's crashed. Bang. You crash. It's a bit morbid, isn't it? So that gives us our landed state. When we're inputting dials for telemetry, we want, and when we're falling, I think that'll be the same for now. Now we need to make this dials thing. I think that can just be dials telemetry. That can just be a div with a bunch of paragraphs. Time. Time. String to from int. Something like that. Let's copy that. And we want to have, as well as time, I think, height, velocity and fuel. Height, velocity, and all these are floats, aren't they? I think I haven't got enough brackets. Oh yeah. So that's looking good. So what do we want? We want some UI, don't we? I can be a div as well, just to make it easier. I want an input. Oops. And we can make that a number input to give us those little things. And we want an on click, no, on input, I think it is. Now we have input string. So for our inputting, let's add some UI to that. That looks good. Oh, we need a button as well, don't we? I don't think it's submit, is it? I need to do on click. Should we call it punch it or something? Trigger burn. Trigger burn. And punch it. So 50. we should see. We can't. Oh, that's interesting. So now we're in the landing state. And when we click on this, nothing happens, even though it looks exactly the same as the trigger state. So I guess the way to do this is to pass in the burn here and then do something like no, wrong place. Add the value here. Value. No, I think it needs to be a string. But we're going to pass in. Our guess is maybe a float. So if we maybe .map on float. I think it's going to complain because that's going to be a maybe, right? So what I want to do is pass in the guess here. And pass in nothing there. Something like that. So 20 budget. Better 20 budget. Right, that looks good. So let's format that. I'm going to save it as well. If you want to join in, you can probably see the URL there. I'm just going to take a copy of that. Okay, this is looking good. We've got another 10 minutes. We need to implement this tick function. And this is going to do all these maths. All this maths. So let's have a look what's happening. So let's see. The new velocity is the old velocity minus the burn plus 5. That's the gravity. So the velocity is going to increase by 5 every tick minus the burn. Okay, that's good. The fuel decreases by the amount of the burn. That makes sense. There's a sort of clamping happening here, so the fuel can't be more than the burn can't be more than the fuel. That makes sense too. So V1 over V2 is the average velocity. So in one tick, it will move. Since that's velocity per tick, it'll move that much. So that's the distance. So if you would have gone into the ground, then it jumps to the crash bit here. Otherwise, it lets the height down. Time goes to 1. And it works out your velocity on landing. I think we can do that quite quickly. So let's have some lets. So the clamp burn equals basics dot the lower of telemetry dot fuel or burn. That makes sense, right? And we want the fuel to equal dot fuel minus the clamped burn. That makes sense. So then we've got the new velocity. So let's just pull that out as a term. Let's call that delta velocity equals, so we want to add on gravity, and we want to minus the clamp burn. That means our new velocity is telemetry velocity minus or plus delta velocity. Cool. So now we can add velocity to this. Now our new height, oh no, average velocity. So our average, so distance traveled equals telemetry dot velocity plus new velocity divided by 2. So the average of those two velocities times is that new height equals telemetry height minus the distance traveled. So I think we can run this now, maybe. Oh, it didn't like that. Oh, I missed a comma. So let's have a burn of 0. Our velocity should go up to 55. Yeah, let's have a burn of 30. Yeah. That looks good. That looks good. So how do we know if we've crashed? Oh, so crashed equals new height is less than or equal to 0. In fact, let's clamp our so our height can't go lower than 0. It feels like we can just state that. So we've crashed. Oh, it's also a bit pessimistic. So if landed, else, then we do something else, we're still falling. Our state is going to change to landed. Let's just have perfect landings all the time. So I'm just going to go 0 so that let's see whether we land. 260, 187, we're going quicker, 110. This one I think is going to be perfect landing. Great. So we need to work out what velocity we landed at. So crash velocity equals, well, I don't know. We need to scale this delta velocity by when we hit the ground. So that will be something like delta velocity, because they're effectively, because the time is 1, it's effectively a distance as well. So times, I don't know, telemetry dot height So if the distance to travel is twice the height, then that delta velocity will be times by half. So I think this is telemetry dot velocity plus I think that's the right calculation. So crash status equals if crash velocity is greater than 5, then crashed, else if crash velocity greater than 1, then bumpy, else perfect. Now we just need to land a crash status. Let's try it. So we'll just do what we did last time. We'll just keep punching in 0. And we should crash pretty severely. Velocity is going to be 825. And we crash, no survivors. Let's try and land this thing. I think we still want to probably let it go, let it travel. Quite a distance before we start burning fuel. I think I'm going to burn half my fuel there. Going at 20. That's okay. We want to. I'm no good at this. So our velocity is 5, our fuel is 25, and we're 37 off the ground. So I think if we do 17 off the ground, we've got 25 fuel. So 20 should bring us to an almost stop. So 5 maybe. That's really, it's quite hard to do. But I think we have the basic game there. And that's not too bad, right? You know, there's a bit that looks straightforward. If landed, then landed, otherwise falling. This kind of stuff doesn't make much sense. Maybe we can pull out some things there. Maybe we can work out what some of these things mean. And this is still a bit messy here, the update method. And that's that model message thing again. Okay. But that'll do for now.